Hi Year 11 Mathematics Advanced students. Today we're continuing on with the topic of Introduction to Calculus and we're looking at tangents and normals. So tangents and normals to our curve is what we're looking at. So we need to remember that the derivative is a function that gives the instantaneous rate of change or gradient of the tangent to the curve. So a tangent is the line. So we can use the formula y equals mx plus c, or y minus y1 equals m bracket x minus x1 to find its equation. So basically what we're doing is we're trying to find the equation, or what we're going to do today is find the equation of tangents or the equation of normals. So to find the equation of a tangent to a curve or normal, we need to find the gradient. So we need to find m by differentiation and substitution as well as the point. So we can use the formulas y equals mx plus c or y minus y1 equals m bracket x minus x1, like I said. So just a reminder of what the tangents are. So the tangent is the line that hits at one point on the curve is our tangent, and our normal is the perpendicular part to our tangent. So it is here and makes a 90 degrees there. So let's have a look at some examples. We want to first find the gradient of the tangent to the parabola y equals x squared plus 1 at the point 1, 2. So we first want to find our gradient. So the gradient, hang on, I'm actually going to write this in green. So the gradient of a tangent to a curve is our dy on dx. So it's when we differentiate. So we need to differentiate our equation that we've been given. So we're going to find dy on dx, which equals y dash also, of our equation y equals x squared plus 1. So what we do is we bring our power down, so it will be 2x, and our constant disappears. So it's 2x plus 0, which just equals 2x. Then we want to substitute our point, our x equals 1, from our point into our derivative. So we're going y dash 1 equals 2 times 1, which just equals 2. Therefore, so the gradient of the tangent at the point 1, 2 is in fact 2. So that's all that we have to do. So the gradient of a tangent is the derivative. So we differentiate our equation and then we substitute in our point. So differentiate our equation and then substitute in our point to find the gradient. Now we want to find the gradient of the normal to the curve y equals 2x squared minus 3x plus 5 at the point where x equals 4. So we're going to do the exact same thing. We're going to find the gradient by differentiating our equation. So we're going to find dy on dx, which equals y dash, if we write it in short form, of our equation. So when we do this, we bring our power down. So it will be 2 times our 4x, or 2 times our 2x, sorry, I'm thinking ahead. Our 2x to the power of 1 minus 3, and our constant disappears. So our y dash equals 4x minus 3. And so then we need to sub x equals 4 into y dash. So we get y dash when x equals 4 is 4 times 4 minus 3, which equals 16 minus 3, which equals 13. And then what we need to do is that, therefore, our m1 equals 13. So we need to remember when we're finding the gradient of perpendicular lines, so because we have our tangent, it is always going to be, so our tangent is always our gradient, m1, which just equals our dy on dx. But for our normal, it is a perpendicular to our tangent. So it is going to be our m2, which equals minus 1 over m1. So this is because they are perpendicular. And because our perpendicular gradient is m1 times m2 equals minus 1, or our m2 equals minus 1 divided by m1. So the gradient, because the normal is perpendicular to the tangent, therefore m2 equals minus 1 on m1. So our m2 will equal minus 1 over our m1 of 13. So our m1 of 13 is what we just found, and we substitute that in. So therefore, the gradient of our normal is negative 1 on 13. Okay, so we just need to remember with our tangent and our normals that they're perpendicular lines, so we need to use what we know about gradient. For equation 3, or for example 3, sorry, we want to find the equation of the tangent and the normal to y equals 3x squared minus 4x plus 1 at the point x equals 2. So what we're going to do is that we first need to find out what our tangent gradients are. So our gradient of our tangent and our gradient of our normal. So to find gradient, we go dy over dx. So dy over dx, which is equal to y dash in shorthand form. We need to differentiate our equation. So it will be, bring our power of 2 down. So it's 2 times 3 is 6. X to the power of 2 minus 1 is just 1. So it's just 6x. Minus 4, and our plus 1 vanishes. And it's at the point x equals 2. So because it's at the point x equals 2, we can sub in x equals 2. So we'll get y dash 2 equals 6 times 2 minus 4. So that is 12 minus 4, which equals 8. Therefore, therefore the gradient of the tangent is m1 equals 8. The gradient of the normal is m2 equals minus 1 on m1. So m2 equals minus 1 on 8. So we have our two gradients there. Now what we want to do, in order to find our equation, we want to use y minus y1 equals m bracket x minus x1. But you'll note we only have the point x equals 2. So we need to find our point. So to find point, sub x equals 2 into y equals our 3x squared minus 4x plus 1. So our y will equal 3 times 2 squared minus 4 times 2 plus 1. So that's y equals 3 times 2 squared. 2 squared is 4, so 3 times 4 is 12, minus 4 times 2 is 8 plus 1. So our y value equals 5. So therefore, we have the point 25. So then to find the equation, of the tangent and normal, sub in gradients and point. So we have our tangent here and our normal. So we have y minus y, well actually let's write our point here. So we have m1 equals 8 and the point 25, and we have m2 equals minus 1 on 8 and we have the point 25. So we've got y minus y1 equals m bracket x minus x1. So let's just focus on our tangent first. So let's substitute these in. So we have y minus 5 equals 8 times x minus 2. So we have y minus 5 equals 8x minus 16 plus the 5 to both sides. And we have y equals 8x minus 11. So that is in our gradient intercept form. So y equals mx plus c. So to get it to general form, we want everything on the one side of the equation. So we're going to minus y to both sides of our equation. So we get 8x minus y minus 11 equals 0. So that is our equation of our tangent. And then to find our equation of our normal, we sub our m2 equals negative 1 on 8 and our point 25 into y minus y1 equals m bracket x minus x1. So we get y minus 5 equals negative 1 on 8 bracket x minus 2. So we're going to multiply both sides by the 8. So we get 8y minus 40 equals, and because this 8 cancels out the 8, I'm also at the same time going to multiply the minus 1 into our bracket. So we minus x plus 2. So then we want everything in general form. So we're going to add to both sides our x and minus our 2. So add our x minus our 2. So we'll get 8y plus x minus 42 equals 0 as our equation